Hi, welcome to your third lecture of Programming Fundamentals using Java language. In this lecture, we are going to learn about variables. Before going further, we need to understand what is a variable actually. So a variable is considered as a placeholder which is used to store some sort of values inside it, and it gives us a reference where we can assign a value and then we can use that value in further computation. Java programming language provide us different type of variables, and those variables are used to store different type of values. We have integral values, decimal values, characters, and even a proper statement which we can store into a particular variable. Imagine this x is a variable and we can store in that variable, as I mentioned, different type of values. For example, it could be integer, it could be a decimal, it could be a character, for example, like t, and it could be a proper statement like this is it. And beside that, we can also store, there is another type of value which we call true or false. It could be a true or it could be a false, and those values have special meaning in programming, which I will explain later. Okay, before understanding variables, we have to see different type of variables provided by Java. So in Java we have like plenty of variables, like for example in specifically the part of integral values, we have a special variable which is called integer, and integer is used to store numbers. So it is used to store any number, like it could be 10, 100, and then we can perform different type of computation over those numbers. So just for this example, let's create a variable type of int. This is basically the type of the variable, this is the reference of the variable, and this is the actual value. As I mentioned earlier, the variable itself is a placeholder, so x is a placeholder which contain this value. So if you want to print that and see what is inside this x, so system.out.println, then you will able to see that the value of x is 1789, which we just created. Okay, so this was just an example to start with, to understand like what is the variable and how we can use that. But we, as I mentioned, we have different type of variables with different type of sizes. So by that what I mean is, so as I mentioned, like the variable itself is a placeholder. You can consider placeholder as a box, and there is a size of a box, so you cannot put more values or more things inside box which is beyond its size. So you have to limit it. You have to put limited things which basically fit in the size of the box. So we have different type of variables with different size. For understanding and to make it more easy, I already created a diagram. So just start with this one. You can see that the smallest box we have in Java is called byte. So byte is a variable which is the smallest box, and it equals to 8 bits. The size of the byte is 8 bits, so you cannot enter value or assign value or number which is greater than 8 bits. So this is the smallest box we have in Java. And then there is a slightly bigger box which comes up with the name of short. The size of the short is 16 bits. So it's more than 8 bits. It's a little bit bigger box, but we cannot store a number which size is greater than 16 bits. Then we have this another type of variable which is called integer, int, and the size of int is 32 bits. As I mentioned earlier, we cannot store a number which size is greater than 32 bits into int. And then we have the biggest one which is called long, and it's come up with 64 bits. So these are more oftenly like the integral, for storing integral values in these data types. And then we also call them data types. These also called data types or variables. So we cannot we cannot store any decimal value in that. And for that decimal, we have two more special classes. One is called float, and the float size is equals to integer size. It's 32 bit. And then we have double, which size is equals to the long size, which is 64 bits. There is another data type, a special type of data type, which is called char, C-H-A-R. It's 16 bit here in Java. Most of people are confused with char because and C++ have different size of char. I think it's 8 bits, 1 byte, but in Java it's usually 2 bytes, 16 bits. And here we can store different characters like A, B, C, any character. And there is another type which comes up with Java, and that is called boolean. You don't need to worry about these names. You will get familiar and get used to those gradually. So don't worry if you don't remember all of these names now, but gradually you will be. So boolean is also another data type which comes up with the size of 1 bit information. It could be a true or false. Now all of these data types are the part of Java, and these we're going to practically see that how we can basically store variable in those and perform mathematical operation. And then we will study a very different variable and a data type which is called string, and that is like way different than these data types. And I will also explain you like what we call them into Java, like these byte, short, int, long, char, float, double, and boolean. Practically these byte, short, int, long, and char, float, and double are categorized as primitive data type, which I will explain later, but like we can see the practical example now. Okay, so let's see that how we initialize a byte value. So let's call it B, and we can store a value of, for example, 110 in it, and then we can just print that. So we can see the value is stored successfully, and we can see on our console that 110 is there. So as I mentioned, like it's only 1 byte is only 8 bits, and then this value have a range of numbers which we can store. So it's come up with a range like from negative to positive, and beyond that range we cannot store value inside the byte. So if you want to see the maximum and the minimum range of byte, what you have to do is you have to write byte with capital B. So byte with capital B and then max value. So you can see that in max value it's written 127. So this is the maximum range of byte data type in Java. And then if you want to see minimum range of byte, then you can again write byte with B capital, and I will explain that what is that B capital here later. So just for now to see that what is the minimum and the maximum range, you have to just write with B capital, and then you can write max value and the min value, and when you're going to print that, you can see that the value is defined here. So what does that mean? The meaning of that is basically you cannot store a value more than 127 and less than -128. So let me store 127 here. You can see that it's successfully stored without any issue. But if I try to store 128 here, you can see a red line which shows that this is a compilation issue. Java IDE basically tell you that you are trying to store a greater number into byte, and IDE basically help you to understand that this is not possible. If you're going to run this application, you will get an error. So like if I'm trying to run that, you can see that the compilation will fail, and there will be an error that possible lossy conversion from int to byte. So incompatible type. So basically it's trying to say that you cannot store the greater value into byte. Likewise, we can store the minimum value of 128 inside it, and that's work fine. But if you try to store 129, it's again complained that this is out of range. So range is basically, if I try to define the range here, it's basically from -128, -127, -126 ... 0 1 2 3 ... to 127. So that is the range of numbers you can store in byte. Beyond those range you cannot store. So that is the limitation of byte. Okay, so byte is 8 bits, and this is the range which I defined above. So Now let's see a slightly greater data type than byte, and which is short S. And short is basically 16 bits. It's double than byte. So we want to see that what is the range which we can store into short. And again, saying that you don't need to remember that range. That is not much important, but just for the knowledge that these typical types have a range where we can store number, and it's very easy to find out without checking by calling the max and the min values. What you can do is basically you have to just write 2 raised to power of size, which is for example byte is 8 bits, so you have to do just 2 raised to power 8, and the value, the answer which you will get, you have to divide those in by 2. So half number goes to the negative and half goes to the positive. Remember that while you're shifting the half number to the negative, you have to keep in mind that positive 0 will include to the positive list. So let me just do a quick calculation here. If I multiply that, just give me a moment, and then it will be I think 256 divided by 2. So the answer will be 2 raised to power 8 will be here 256, and you have to divide it by 2, which will be 128, which will be 128. Now, as I mentioned, like 0 is the part of positive number. So if you split 128 into positive and negative, then the range of the positive number will be 0 to 127, which in total are 128 numbers, and the negative range will be -1 to -128, because that's basically the total 128 number. So it's very easy. It's a very simple mathematical calculation. You have to do like 2 raised to power 16. I'm not going to do for all of these numbers, and then you have to divide it by 2, and then you have to divide all of these numbers in positive and negative. Okay, to understand like what is the minimum value for short, again we have to write short with capital S, and the min value is this, which you can see here, and the short dot max value is this. Okay, if I'm going to run it, you can see the minimum and the maximum value in console. I'm just going to pick the maximum one and just try to store that into short, and then you can see that it's successfully stored. But when I'm going to increase that value, it will complain again that this is out of the range of short. Okay, so the other data type which is slightly greater than short is called integer, and integer is basically 32 bits, which is double than short. And we have the range of integer as well. So like if I'm just going to quickly print that for you, integer dot max value, and then min value. So it's a very big number, so that's why it's the value is shown into hexadecimal here, but okay, that's the number. So this is the range of integer, and you cannot store more than or less than that range in integer. And then we have lastly, for integral, we have long. So long is basically double than integer, 64 bits. Now there is a tricky part here. You have to understand this. When you try to store a number into long, the number for reducing space, Java is an intelligent language, so it try to utilize your space. So when you try to store a number into long, it store that number automatically as an integer. So imagine that this number is very small for long, right? And Now what happened is 64 bits is a big space actually. So Java does not want to utilize, whenever you're going to create a long variable with a number, Java does not want to create a 64 bit of space into your memory. So because it will occupy a lot of space, and imagine that with this 64 space you are just utilizing like few bits, like 123, and the rest of the space is empty. So what it does, Java usually, for the safer side, it use the half of the space as an integer. Why I'm saying so? Because let me just quickly give you the reason. Like, so let's try to print the maximum value of integer here on the console, and this is the maximum value of integer. Let's copy that and try to store that into long. It's perfectly stored, but when I'm going to increase that, it will complain. It will say that the number you are trying to store is beyond the limitation of integer, although I'm storing it into long. That's a very surprising thing for me. So if you're trying to store a number into long, it should have more range as compared to integer, but that does not work in Java. So long is a very big value. So Java just try to utilize space and convert your value into integer into a smaller space and then store into long, although the type is long here. So if you want to forcefully tell Java to store that value as long, so if I want to forcefully tell my compiler that I don't want to worry about space, I just want to store that value as long. However, the value is smaller or lesser range than long, it's small value, I don't care, but still store that as long. So what I have to do here is to add L at the end of the value. You can add smaller L or the capital L, that's fine. So both will work. Now my code will tell Java that no, this value is a long value and occupy all of 64 bits on the memory, although it's not recommended. So whenever you're trying to utilize long values, just try to keep values as it is, without, for example, L. But yeah, if you are doubtful and you know that the value could increase the range of the integer limit, so you can add L at the end. So then now the value will become long. Actually, the space will be occupied for long. Okay, now try to print that, and you can see the value is on the console. Okay, so this is all about the integral values like byte, short, int, and long. Now let's see the decimal value we have. So if you want to use a decimal value, we use a data type called double. And from the diagram I showed you, this is the double, and that's equals to the size of long, which is 64 bit. So I will explain you about float in a couple of minutes. Okay, so double size is exactly the same as long, 64 bits, but now that particular data type used to store decimal values. So that by decimal value I mean like there will be some values before point and there will be some after dot after point. So just try to print that, and we can see here is the value is successfully stored. Okay, now there is another data type which is used in Java to store decimal value, which is called float. But there is a problem when you store value in float. So you have to remember that whenever you use a decimal value, that's very strange because Java behave differently for different data types. So whenever you use a decimal value, it considered as double by default in Java. So whenever you use a non-decimal value, a normal number, it considered as integer by default in Java. So let me write this. So non-decimal values in Java consider as integer, by that I mean int, in Java. Okay, I already wrote in Java. And the decimal values in Java consider as double, and this is the default behavior of Java. Default mean Java act like that whenever you try to initialize these type of values. Like I mentioned earlier, like when I was trying to store a number into long, unless I use a postfix of L, it considers as an integer. So here, when I'm trying to store a decimal value in float, by default Java think that that's a double value. That's the default behavior of Java. And when we try to store that value into float, it gives us error, compilation error. It says that you are trying to store double value into float. So to tell Java, no, this is not a double value, this is a float value, we have to add F postfix after the value. Now Java will able to understand that this is a float data type, and it will consider as float value. Okay. Okay, let me just quickly run that, and we can see the values are on the console. Now, what is the reason behind it is because, like, for the floating numbers, Java basically use 64 bits and consider those numbers, those decimal numbers, as double, and use 32 bits before insertion points and use 32 bits the number after insertion point. So 32 bits for both of these partitions, before and after insertion point or before and after decimal, is reasonable, and it's used to store those values effectively, and 32 bits is the size of the integer, so both values are considered as integer, and both are safe to store into 32 bits. So float, on the other hand, have a size of 32 bits, and that size, if we divide that into 2 before decimal point and after decimal point, so it become 16 and 16 bits. 16 bits before decimal and 16 bits after decimal, which is a lesser range to store a number. So that's why on the safer side, Java usually use double as a default, and we should use default as well. Like I recommend to use double as compared to float if you want to achieve accuracy and you don't know the size of the number. If the number is really small, like 2. In between the range of 1.1 to 1.10, then we can use float. Otherwise, I don't recommend you to use float here. Okay. Now, let us see the character data type. So, in character, we can store any character, like for example, A to Z, and from capital A to capital Z, or any sort of special character. So, the character is 16 bits, which is 2 byte. So in Java we have 2 byte character, while I think in C is like 1 byte, but I'm not 100% sure. So anyhow, let's try to print that character on the console and see what we have here. So you can see the character itself. Okay, another interesting part about character is, for each character there is a ASCII. The ASCII is basically a number. So each character have a special number, and it's a distinct number. So A to Z, all of these characters are assigned with the number, and capital A to Z are also assigned with the number, which are different from each other. And if you want to see that number for that particular character, you have to just type bracket here and then write int. Now this int, this is called casting. We will study that casting and boxing in future, but just to understand that is basically it will read our character and convert that character value into integer. So it will give us the number of that particular character. Don't need to worry about that right now. We will study that boxing, unboxing, casting, up casting, down casting in future, but just to show you like how we can fetch the numeric value of character from the value, we have to just type brackets and then type the value integer itself, and in the console we can see there will be a number. Okay, so the value of small z is 122. Okay, I'm just going to write down the print statement for character. I'm going to comment out this, and the last type will be boolean. So boolean is a very special type in Java in which we can store only 2 types of value. Either it could be true or it could be false. So there will be only two type of values in boolean, true or false, and that's a very useful type. We will study that in further in our conditional statement, loops, if else or switch statement. But this data type have a size of 1 bit. It's 1 bit of information, 0 or 1. In programmatic terms we call it 0 or 1, and then we can print that and see the value of it. So it will be true now. Okay, so I think we already covered all of the primitive. Okay, so all of the data types are covered for now. We will discuss string into next lecture, because it's a there will be a long information. There will be a huge information and explanation required to understand string there. But okay, let me just give you a brief introduction about primitive data types. So all of these data types which I wrote here was byte, short, int, long, char for character, float, double, except of boolean. So I'm not including boolean here. These data types are called primitive data types. So what we call those data types? Primitive data types. So primitive data types are special data types which is used to drive other data types and to build. These are coming from the old languages, which is a part of C++ and the C, and then go back to the all other old AD languages, and then they are coming from all of these construction programming fundamentals from our past, and then become the part of our programming, and then these types are used to drive the more data types, more complex data types. So that's how we call those primitive data types, and this lecture was the introduction of about these data types. Okay, I think that's all for this lecture. If you have any question, just comment out in the video and I will try to reply those. If you like my lecture, just follow the channel for the next lectures, and we will study further and see other complex structures in future. Thank you so much.